Welcome to this lesson on AI and the future of construction management. Construction projects today are becoming larger, more complex, and more difficult to coordinate. A single project may involve hundreds of workers, multiple subcontractors, tight schedules, changing site conditions, and a large amount of information moving between the office and the field. Yet, many project teams still depend on spreadsheets, emails, PDF files, phone calls, and software systems that do not always communicate with one another. This creates a major gap between the information a project produces and the information managers can actually use at the right time. That gap can lead to delayed decisions, missed warning signs, cost overruns, schedule impacts, safety concerns, and quality problems. This is where artificial intelligence can provide real value. AI can help project teams collect, organize, and analyze information earlier. Instead of waiting until a problem has already affected the field, managers can use AI-supported insights to identify risks sooner and respond more proactively. The key idea is not that AI replaces construction management. The key idea is that AI can help construction managers make earlier, better informed decisions before small problems become major disruptions. A useful way to think about AI in construction is to see it as a co-pilot, not as the commander. AI will change how many construction roles are performed, but it will not eliminate the need for human judgment. Construction is not a purely digital activity. It takes place in real physical environments with real people, real contracts, real safety risks, and real financial consequences. AI is very strong when the task involves large amounts of information, repeated administrative work, pattern recognition, or rapid comparison of alternatives. For example, AI can help organize project documents, summarize reports, compare drawing revisions, test schedule scenarios, flag unusual cost patterns, and identify visible safety concerns. These are valuable capabilities because they can reduce time spent on repetitive work and allow project personnel to focus more on planning, coordination, problem solving, and communication. However, AI cannot replace the core responsibilities of a construction manager. It cannot rebuild trust with an unhappy owner. It cannot negotiate a difficult trade-off with a subcontractor. It cannot fully understand the field context behind a superintendent's judgment, and it cannot accept professional responsibility for a project decision. That is why leadership, accountability, communication, and judgment remain human responsibilities. AI can provide alerts, summaries, forecasts, and possible scenarios, but the construction manager must still decide what action is appropriate. AI can support many parts of the construction life cycle. The most useful applications are those that improve decisions related to cost, time, safety, quality, communication, and equipment performance. In estimating and pre-construction, AI can help compare historical cost data, regional price trends, market conditions, project scope, and design alternatives. When connected with BIM, AI can support better decisions before construction begins by helping teams evaluate cost, constructability, schedule impact, or even energy performance. In predictive scheduling, AI can test different construction sequences, identify activities that are likely to affect the critical path, and help project teams evaluate recovery options when delays occur. For example, if material delivery is delayed or labor availability changes, AI can help managers study alternative responses more quickly. In safety and quality, computer vision and sensor-based systems can help identify visible hazards, missing personal protective equipment, equipment proximity risks, defects, or deviations from design intent. These tools do not replace safety professionals or inspectors, but they can help focus attention on areas that need timely review. AI can also support documents and communication. Construction projects produce large amounts of written information, including RFIs, submittals, meeting minutes, specifications, contracts, change orders, and daily reports. Natural language processing and large language models can help organize, summarize, draft, compare, and retrieve this information more efficiently. Finally, in equipment maintenance, AI can analyze telematics and sensor data such as operating hours, fuel use, vibration, temperature, and idle time. By identifying early signs of abnormal performance, AI can help contractors plan maintenance before equipment breakdowns disrupt the project. Across all of these examples, AI is most valuable when it is connected to reliable project data and reviewed by qualified professionals. AI can provide important benefits in construction, but those benefits must be balanced with its limitations and risks. The main benefits include faster information processing, earlier risk recognition, reduced administrative burden, improved cost and schedule visibility, and stronger safety monitoring. By helping teams analyze information more quickly, AI can shorten decision cycles and allow managers to respond before problems grow. However, the most important limitation is data quality. AI systems depend on the information they receive. In construction, project information is often fragmented across spreadsheets, emails, PDFs, scheduling tools, accounting systems, BIM models, subcontractor platforms, and field reports. If that information is incomplete, outdated, inconsistent, or poorly connected, the AI output may also be unreliable. In other words, poor data can lead to poor AI results. There are also serious risks. AI may generate incorrect or unsupported information. It may create cybersecurity or privacy concerns. It may produce biased results if the training data or project data are biased. It may also experience model drift, where the system becomes less reliable as project conditions change over time. There are also legal and professional responsibility issues. If an AI-generated recommendation affects cost, schedule, safety, quality, or contract rights, the project team must be very careful before acting on it. For that reason, AI should never be treated as an independent authority. The more important the decision, the more carefully the AI output must be reviewed by a qualified person. For construction managers, the most important question is not whether AI is impressive. The real question is whether AI improves project performance in a controlled and responsible way. There are 5 key lessons. First, start with a real management problem. AI implementation should not begin with the purchase of a new software product. It should begin by identifying where the company loses time, money, or control. Examples may include slow RFI cycles, late cost warnings, repeated safety issues, unreliable progress reporting, or inconsistent estimating assumptions. Second, build reliable data first. Field reports, schedules, cost records, submittals, RFIs, drawings, BIM models, and inspection records must be organized, accessible, and trustworthy. Without reliable data, even the most advanced AI tool will have limited value. Third, fit AI into the workflow. AI should support how project teams actually work. If a tool requires duplicate data entry, produces alerts that no one reviews, or creates outputs that are not tied to responsibility, it may create more confusion instead of improving performance. Fourth, prepare the workforce. Construction professionals do not need to become data scientists, but they do need to become informed users of AI-supported systems. They must understand what the tool can do, what it cannot do, and how to evaluate its output. Finally, keep humans in the loop. AI can support decisions, but people remain responsible for them. Construction managers must review AI-generated schedules, cost forecasts, safety alerts, quantity takeoffs, summaries, and contract-related recommendations before they are used for project action. The central message of this lesson is simple. AI can help construction managers move from reactive coordination toward more proactive, evidence-based decision-making. But that only happens when AI is supported by reliable data, clear workflows, trained users, and responsible human judgment.